Now the 16th and one of the very important transformation is to plot inequalities from the given equality. So I'll take up an example. I'll draw this straight line. So when x is 0, y is 2 and y is 0, x is minus 2. So I'll draw this line. In order to determine the region represented by this inequality, what I'll do is I'll draw the graph of y equals x plus 2 and then I'll take up any random point on either side of this graph. So the simplest point is origin. So what I'll do is I'll put the value of x and y in the given inequality. So if I'll put x and y as 0, I'll get 0 is greater than equal to 2. Now, which is incorrect. So that means the solution to my inequality or the region represented by this inequality will lie on the other side of this point. So solution to this inequality will be the region which lies above the line. I'll take up another example. Say for example, I need to draw this region. Y square is less than equal to x. So my basic graph here is y square equals to x. So I'll draw this graph. Now because origin already lies on this graph, so I'll choose another point. So I'll maybe choose this point 1, 0. So I'll put it there. So if I'll put 1, 0, so if I'll put y as 0, I'll get what? 0 is less than equal to 1, which is true. So that means my region will lie inside of parabola. So y square is less than equal to x is the region inside this parabola. 2x plus y is greater than 6. So again, I'll draw the straight line. 2x plus y equals to 6. Now because there is no equality here, so what I'll do is I'll draw this line, but I'll draw a dotted line. So I won't include the points on this graph. That's the line 2x plus y equals 6. Now again, I'll take origin. So if I'll put origin, so if I'll put x as 0 and y is 0, so I'll get what? 0 greater than 6, which is incorrect. So that means it will lie on other side of the origin. Answer to this inequality is region which lies above this straight line. And here I have not included the points on the line. I'll take up another example. Say for example, I have to find the region bounded by this circle, which is x square plus y square equals 4. So this is x square plus y square is equal to 4. And because it has an equality sign, so I have drawn a solid circle. If I'll put origin, I'll get 0 is less than equal to 4, which is true. So that means the region represented by this inequality is all the points on and inside the circle. Now I'll draw this parabola, and because there is no equality sign, I'll draw a dotted parabola. So that means points on the curve, they won't be included. So I've drawn the graph of y equals 2x square with a dotted line. Now I'll take up any point. I cannot take origin because it lies on this parabola. So I'll choose another point. Maybe I'll choose this point. This point is 0, 2. So I'll put 0, 2. So if I'll put 0, 2, y is 2 and x is 0. So 2 is greater than 0, which is true. So that means it will represent all the points inside of this parabola. So the region which is common to both the circle and parabola is this region. Points on the circle, they are included, and points on the parabola, they are not included. I'll take another example. Say for example, represent the region x square is less than equal to y is less than equal to mod x. So my first graph is y equals x square. So I'll draw the graph of y equals x square. And then I'll choose any random point. Maybe I'll choose 0, 1. I'll put it in the inequality. So x is 0, y is 1. So that means it will represent all the points which will lie inside this parabola. Now I'll come to the second graph, and second graph is y equals mod of x. So I'll draw y equals mod x. Now again, I'll choose this point 0, 1, and I'll put it in this inequality, which is y is less than equal to mod of x. So if I'll put y as 1, x is 0, which is false. So that means it'll be outside of this modulus function. So the region represented by this inequality is the region which I have drawn in red. What about this question? Represent the area bounded by the curves mod of y plus x is less than equal to 1 and mod of y minus x is less than equal to 1 and x square plus y square is greater than equal to 1 by 2. Now for this one, I can simply write it as when mod of x is less than a, then x lies between minus a and plus a. And for this one, again I can write minus 1 is less than y minus x is less than plus 1. So I'll draw the two straight lines. X plus y is equal to minus 1. And for x plus y equals to plus 1. So this is x plus y equals 1. Now what about this? Now y minus x equals minus 1. So which is when x is 0, y is minus 1, and when y is 0, x is plus 1. So that is y minus x equals minus 1, and this one is y minus x equals plus 1. So when y is 0, x is minus 1, and when x is 0, y is plus 1. So now I'll take any random point. I'll take this origin. So if I'll put this origin here, so if I'll put x and y is 0, I'll get what? Minus 1 is less than equal to 0 is less than equal to 1. So that means I'm looking for area in between these two lines. And what about this? Minus 1 to plus 1 y minus x. Again, if I put origin, I'll get minus 1 is less than 0 is less than 1. So then again, I need area in between these two lines. So that means the area which is common to the two given inequalities is this square. Now we'll come to the third one, and the third one is x plus y is greater than equal to 1 by 2. So now it represents a circle with center at origin and radius as 1 by root 2. So length of the set of the square is under root 2. And if I'll draw a circle with center at origin and radius as 1 by root 2, so this circle will touch all the four lines. Now if I'll put origin here inside the circle, I'll get what? 0 is greater than equal to 1 by 2. So that means region which lies outside the circle. So that means the answer to this question will be the region represented within the square which lies outside the circle. So that's the region we are talking about. Now the sixth transformation that we'll study is how to draw the graph of piecewise defined function. A piecewise defined function is a function with multiple subfunctions. Such functions will have different definition in different intervals. For example, fx is given by 2 plus x whenever x is less than 0, 1 minus x when x lies between 0 and 1, and under root of x minus 1 when x is greater than or equal to 1. So if I have to draw this graph, I'll draw the axis. Now this first subfunction y equals 2 plus x is actually a part of a straight line. So I'll draw this part of a straight line. So when x is 0, y is 2, and because 0 is not included, I'll put an open circle at 2, and when x is minus 2, this value is 0. So I'll draw this straight line. So this portion of function is x plus 2. Now between 0 and 1, it again represents a straight line which is y equals 1 minus x. Now when x is 0, y is 1 and 0 is included. So I'll mark a point at 1, and when x is 1, y is 0. So again, I'll join these 2 points. So it is 1 minus x. Now for the third part, my basic function is y equals under root of x, and then I'll move this function plus 1 units along x-axis. So that's the graph of square root of x minus 1, and value at 1 is included. So this is the graph of the given function. So this function is discontinuous at x equal to 0, and it is not differentiable at x equals 0 and 1. I'll take up another example. Now suppose the function is defined as 2 minus x when x is less than minus 1, 3 when x lies between minus 1 and plus 1, and 4 minus x square when x is greater than 1. So again, I'll draw the axis. So this first subfunction again is a straight line, which is y equals 2 minus x. So when x is minus 1, this value is 3. And when x is minus 2, this value is 4. So I'll draw this portion of straight line. Now between minus 1 and plus 1, it's a constant function and its value is 3. When x is greater than 1, in this case, it represents a parabola which is y minus 4 equals minus x square. So my basic graph is y is equal to minus x square, and then I'll shift the graph plus 4 units along y-axis. Now when x is 1, y is 3. So That will be the graph of 4 minus x square. In this video, we'll study how to find composite function from piecewise defined functions. Now, basically, there are two methods. One of them is graphical method, and the second one is algebraic method. So we'll study these two methods with 3 graded examples. Now, this first example is, we are given this function fx, which is defined as minus 1 plus mod of x minus 1 when x lies between minus 1 and 3. Now, clearly fx, it is a continuous function, and we have this mod x minus 1. Now, root of x minus 1 is 1, rightmost plus, this is minus. So when x is less than 1, it takes a negative value, and when x is greater than 1, it takes a positive value. So we can write this function fx as, now for this first interval, when x lies between minus 1 and 1, we have this minus sign here, so it will be minus 1 and then minus x minus 1, and then we have the second interval where x lies between 1 and 3, so it will be this minus 1 plus x minus 1. So basically this function fx is defined as minus x when x lies between minus 1 and 1, and it is x minus 2 when x lies between 1 and 3. Now we look at our function gx. Now gx is defined as 2 minus mod of x plus 1 when the value of x lies between minus 2 and plus 2. X plus 1 has a critical point at minus 1. This is plus and this is minus. So now we can write this function gx as, now first we have this interval when x lies between minus 2 minus 1. Now it is 2, and then in this interval this is negative, so minus minus plus, so it will be this 2 plus x plus 1, and then we have from minus 1 to 2. Now here it will be positive, so it will be 2 minus x plus 1. Now gx is basically x plus 3 when x lies between minus 2 and minus 1, and it will be 1 minus x when x lies between minus 1 and 2. Now we need to find f of gx and g of fx. Now first we'll find f of gx using graphical method. So we are going to use graphical method, and we wish to find f of gx. Now basically f of gx is f and then gx. So essentially values of x will go into this function g, and then value of gx will go into this function fx. Now in this graphical method, what we do is, first step is we'll draw the graph of gx. Now gx is x minus 3 when x lies between minus 2 and minus 1. So between minus 2 and minus 1, this is x minus 3. Now we put x as minus 2, this value is 1. And if we put x as minus 1, this value is 2. So this is a straight line. So this function is x plus 3. Now for this next part, it is also a linear function. So at minus 1, this value is 2. And at 2, this value is minus 1. And at 0, this is 1. So this is 2, then 1, then 0, and then minus 1. And here this definition is 1 minus x. Now there is a definition change at minus 1. So we'll highlight this minus 1. So first step is draw the graph of gx. Now this graph is defined between minus 2 and plus 2, and there is a definition change at minus 1. Now the next step is draw horizontal lines at boundaries of definitions of fx. Now boundaries of definitions of fx are at minus 1, 1 and at 3. So what we'll do is
we'll draw a horizontal line at -1. So we'll draw this horizontal line at -1. We'll draw a horizontal line at 1. And we'll draw a horizontal line at 3. And in addition to it, we'll write definition of fx. Now, when x lies between -1 and +1, definition of fx is -x. So we'll write -x in between these two lines. And when x lies between 1 and 3, this definition is x minus 2. Now, we'll mark all those points where these lines, they're going to intersect the graph of gx. Now, they're intersecting at this point, and at this point, and at this point. So we have already marked this point. Now this is x equals 0, and this point is x equals 2. So now we'll start writing the definition of f of gx. Now first definition is between -2 and -1. So when x lies between -2 and -1. Now in this case, since both the functions fx and gx, they are continuous, we need not bother about this equality sign. We can take it with this definition, or we can also take it with the next definition. Now in this interval, definition of gx is x plus 3, and this definition will go into this x minus 2. So it will be this x plus 3 minus 2. Now this next interval is between -1 and 0. So it will be this -1 x and 0. And in this case, definition is 1 minus x. Now this 1 minus x, it still lies in this interval. So here 1 minus x will again go to this x minus 2. So it will be this 1 minus x minus 2. And then we have this third definition when x lies between 0 and 2. And in this case, definition is 1 minus x. But here graph lies in between these two lines. So here this definition will go to minus x. So it will be this minus and 1 minus x. So basically f of gx will be x plus 1 when x lies between -2 and -1. It will be minus x minus 1 when x lies between -1 and 0, and it will be x minus 1 when x lies between 0 and 2. So this is our graphical method. Now we'll come to algebraic method. Now before algebraic method, we'll write fx and gx again. Now fx is minus x when x lies between -1 and 1, and it is x minus 2 when x lies between 1 and 3, and gx is x plus 3 when x lies between -2 and -1, and it is 1 minus x when x lies between -1 and 2. Now again we'll find f of gx. So we'll write f of gx. Now in this definition we'll replace x with gx. So it will be this minus gx when gx lies between -1 and 1, and it will be gx minus 2 when gx lies between 1 and 3. So for this f of gx, we have defined everything in terms of gx. Now this gx itself has two definitions, x plus 3 and 1 minus x. So what we'll do is, now we'll expand it in 4 parts using definition of gx. Now first we'll use this definition, x plus 3. So it'll be this minus, and then gx is x plus 3, and then we'll write minus 1 when gx is x plus 3 less than 1. Now here we have to use AND, because this condition, it must be satisfied for these values of x. So together with this condition, we have to take into consideration domain of x also. So it will be this minus 2 x and then minus 1. Now we'll put this x plus 3 in this second definition. So it will be this x plus 3 minus 2 and then 1, and then it will be this x plus 3 less than equal to 3, and again where x lies between minus 2 minus 1. Our next definition is 1 minus x. Now we'll put 1 minus x in this first one. So it will be minus 1 minus x and then minus 1. 1 minus x is less than 1. And here the condition is the value of x must lie between minus 1 and 2. And then this definition will go into the second part. So it will be this 1 minus x minus 2 when 1 is less than 1 minus x is less than equal to 3 and minus 1 is less than x is less than equal to 2. And this what we'll do is we'll first solve these intervals. Now this is a minus 4 is less than equal to x and this is less than minus 2, and here it is x lies between minus 2 and minus 1. Now there is nothing common in between these two conditions, so here there is no intersection of values of x possible. So this definition, it is not possible. Now if we look at this, now if we take this 3, then it will be this minus 2 and then x will be this 0, and here it is minus 2 x and minus 1. So in this case we have this common interval between minus 2 and minus 1. So now we write this f of gx, and the first interval where it is defined as between minus 2 and minus 1, and here this definition is simply x plus 1. Now we'll solve this. Now if we subtract 1, it will be this minus 2 less than equal to minus x less than 0, and if we take this minus sign, then it is between 0 to 2, and here it is between minus 1 to 2. So the common interval between these two is value of x lies between 0 to 2. Now here this definition is x minus 1, and finally here it is 0 and then minus x and then 2. So between minus 2 and 0, and here it is from minus 1 to 2. So if we take intersection of these two intervals, it will be between minus 1 and 0, and here this definition is minus x minus 1. So that is the definition of f of gx using algebraic method. Now once we have this definition of f of gx, we can draw its graph. Now when x is minus 2, this value is minus 1. When x is minus 1, this value is 0. So this is x plus 1. Now when x is minus 1, this is 0. And when x is 0, this is minus 1. So this is minus x minus 1. And here, if we take x as 0, it is minus 1. And at 2, this value is 1. So that is the graph of f of gx. Now clearly, this function is continuous in minus 2 to 2, and it is not differentiable at these 2 points where we have these corners. So not differentiable at x equals minus 1 and x equals 0. So this is how we can write composite functions from the two given functions fx and gx. Now we'll draw the graph of g of fx, and here I'm just going to use graphical method. Now for g of fx, it is g of fx. That means value of x will go into f and value of fx will go into g. So here we'll have to draw the graph of fx. So first we'll draw the graph of fx. Now this fx is minus x between minus 1 and plus 1. So at minus 1 it is 1 and at plus 1 this is minus 1. So that's the definition of fx between minus 1 and plus 1. So this is your minus x, and then at 1 this value is minus 1, at 2 it is 0, and at 3 this is 1. So that's the definition, x minus 2. Now there is a definition change at 1. So definition changes at 1, and then boundary values are minus 1 and 3. Now we'll draw horizontal lines at boundary conditions of gx. So we'll draw a horizontal line at minus 2. So it will be this minus 2. And then at minus 1. And then we'll draw a line at 2. Now when x lies between minus 2 and minus 1, definition is x plus 3. So here we'll have x plus 3. And here when x lies between minus 1 and 2, it is the one minus x. Now it intersects only at one point, and this point is already marked. So here we just have two definitions. So if we write g of fx, now this first interval is from minus 1 to 1. So when x lies between minus 1 and 1, definition is minus x, and it will go into this 1 minus x. So it will be this 1 plus x. And then next interval is from 1 to 3. So when x lies between 1 and 3, here the definition is x minus 2, and it'll still go to 1 minus x. So it will be 1 minus x minus 2. So this function will be 1 plus x when x lies between minus 1 and 1, and it will be 3 minus x when x lies between 1 and 3. Now we'll draw the graph of g of fx. Now for g of fx, when x is minus 1, this is 0. And when x is 1, this is 2. So it is this line 1 plus x. And when x is 1, it is 2. And when x is 3, it is 0. So that's the definition. 3 minus x. Now this g of fx, it is continuous in minus 1 to 3, and it is not differentiable at x equals 1. So this function, it is not differentiable at this point, x equals 1. So we can solve these composite functions either using graph or using this algebraic method. Now we'll take up the second example. Now here the question is, we are given this function fx, which is x plus 2 when x lies between minus 4 and 0. There is 2 minus x square when x lies between 0 and 4. We need to find f of fx, domain of f of fx, and also we need to comment upon the continuity of f of fx. Now since this is f of fx, first we'll draw the graph of fx. So we have these x's. When x is minus 4, this value is minus 2. And when x is 0, this value is plus 2. So this is minus 2 and this is plus 2. And here when x is 0, this is 2. And when x is 4, this is minus 14. So at 4, this is suppose minus 14, not to be scaled. So here this definition is x plus 2, and here this definition is 2 minus x square, and there is a definition change at this point 0, and the boundary points are minus 4 and plus 4. Now we'll draw horizontal lines at minus 4, 0 and 4. So we'll draw a horizontal line at -4, a horizontal line at 0, and a horizontal line at +4. And we'll mark these point of intersections. So we have this point, we also have this point, and then we have this point. Now we'll find these points. Now if x plus 2 equals 0, this point is -2. If 2 minus x square, it is equal to 0, then this point is √2. And here this point is intersection of this graph, which is 2 minus x square with this line, which is -4. So this point is actually √6. Now in between -4 and 0, definition is x plus 2. So here this definition is x plus 2. And in between 0 and 4, this definition is 2 minus x square. So now we'll start writing f of fx. So we have f of fx. Now first interval is between -4 and -2. So when x lies between -4 and -2, now since this function is continuous, again we need not bother about this equality sign. So here this definition is x plus 2. And this definition, it lies within these two lines. So this x plus 2 will go to x plus 2. So here it will be this x plus 2 plus 2. Now this next interval is between -2 and 0. So when x lies between -2 and 0, again this definition is x plus 2. Now it will go to this 2 minus x square. So it will be this 2 minus x plus 2 whole square. Now the next one is from 0 to √2. So when x lies between 0 to √2, definition here is 2 minus x square, and we'll go to this definition. So it will be this 2 minus x whole square. Now this next interval is between √2 and √6. So when x lies between √2 and √6, here this definition is again 2 minus x square. Now I'll go to this x plus 2. So it will be 2 minus x square plus 2. Now when x lies between √6 and 4, we have this definition which is 2 minus x square, but then here definition of fx does not exist. So this is the only definition possible for f of fx. So we can write this as x plus 4 when x lies between -4 and -2, and this 2 minus x plus 2 square when x lies between -2 and 0. This is 2 minus x whole square when x lies between 0 and √2, and then it will be this 4 minus x square when x lies between √2 and √6. Now this function is defined from -4 to √6. So domain of f of fx will be from -4 to √6. Now since fx is continuous, its composition with itself will also be a continuous function. So this function will be continuous in its domain, which is from -4 to √6. So this is our graphical method. Now we'll solve this question using algebraic method. Now for algebraic method, we have this fx, which is defined as x plus 2 when x lies between -4 and 0, and it is 2 minus x square when x lies between 0 and 4. Now we need to find f of fx. Now f of fx is fx plus 2 when fx lies between -4 and 0, and it will be 2 minus fx square when fx is greater than 0 but less than 4. Now we have two definitions of fx. So we'll split this definition in 4 parts. So now we are going to write this definition. Now first we'll take this x plus 2. So we'll put fx as x plus 2 in these two. So it will be x plus 2 when x plus 2 lies between -4 and 0, and this condition, which is when x lies between -4 and 0. And the next one is 2 minus x plus 2 square when x plus 2 lies between 0 and 4, and again it is true when x lies between -4 and 0. Now we have this other definition, which is 2 minus x square. So it will be this 2 minus x square plus 2 when -4 is less than or equal to 2 minus x square is less than or equal to 0, and here value of x lies between 0 and 4, and then we have 2 minus x square whole square when 0 is less than 2 minus x square is less than 4, and x lies between 0 and 4. Now first we'll simplify these intervals. Now here the value of x is -6 is less than x is less than -2, and here it is from -4 to 0. Now if we take intersection of these two conditions, we'll get the value of x between -4 and -2. So first definition is from -4 to -2, and it will be this x plus 4. Now for the second one, it will be this -2 and then x and then 2, and here it is from -4 to 0. So here common between the two is from -2 to 0. So next one is from -2 to 0, and here this definition is 2 minus x plus 2 whole square. Now in this, if we solve this, we can write this as -6 is less than or equal to -x square is less than or equal to -2, or if we multiply with minus and take square root, it will be this x will lie between √2 and √6, which lies in this interval. So here this condition is the value of x should lie between √2 and √6. Now in this interval, value of fx is 4 minus x square. And finally, we have this, which is -2 is less than -x square is less than 2. So here we'll have mod of x is less than √2. So this is from 0 to √2. So when x lies between 0 and √2, this definition will be 2 minus x square whole square. Now again, it goes from -4 to -2, -2 to 0, 0 to √2, and √2 to √6. So for this, f of fx domain is from -4 to √6. Now, if we look at continuity, we'll check continuity at -2. So f -2 negative, it will be 4 minus 2, 2, and then f -2 positive, and since equality sign is here, so this is also equal to f2, and f2 positive will be 2 minus 0. This is 2, so it is continuous at -2. Now we'll check continuity at 0. f0 negative is also equal to f0, and here if we put x as 0, it will be 2 minus 4, so it will be this -2, and f0 positive, it will be 2 minus 4, which again is -2, so it is continuous at 0 also. Now we'll check its continuity at √2. Now f of √2 negative, now this is 0, 2, and f of √2 will be equal to f of root 2 positive, and here it will be 4 minus 2 and it is 2. So this function is continuous in its domain. So we can find f of fx using graphical method as well as using algebraic method. Now we'll take this third case where we're given this fx and gx and we need to find g of fx. Now first we'll use graphical method. We'll draw the graph of fx. Now when x is 0, this is 1, and when x is minus 1, this is 0. So that is the definition of fx, and since 0 is not included, it will be this open interval. And then when x is greater than or equal to 0, this is x square. So it is x square when x is greater than or equal to 0. So in this case, this fx, it has this discontinuity at 0. Here there is a definition change at 0. Now we'll draw horizontal lines at minus 1 and 1. So we'll draw horizontal lines at minus 1 and also at plus 1. Plus 1. Now we'll find their point of intersection. So we have this just one point of intersection here. We have another point of intersection which is given by this value. Now this point is graph of x plus 1 intersecting this line minus 1. So x plus 1 equals minus 1. So this point is minus 2. So basically this point is x plus 1 equals minus 1. And we also have another point of intersection, and this point is this graph of x square intersected by y equals 1. So if x square equals 1, this point is also 1. So here we have three critical points: minus 2, 0 and 1. Now when x lies between minus 1 and plus 1, definition of gx is 2x, and when x is greater than or equal to 1, this definition is 3 minus x. Now we will start writing g of fx. Now this first interval is x lies between minus 2 and not included 0. Here this definition is x plus 1, and we will go to this definition which is 2x. So it will be this simply 2x plus 1. Now here, since this function is discontinuous at 0, we do not know whether we have to include 0 here or we have to include 0 in the next one. So what we'll do is, as of now, we won't bother about this equality sign. Now we'll find definition between 0 and 1. So when x lies between 0 and 1, here this definition is x square, and still between these two lines. So we'll go to this definition 2x. So it'll be this 2x square, and finally it'll be this x greater than 1. In this we have x square, and now I'll go to this 3 minus x. So it'll be this 3 minus x square. So that is the definition of g of fx. Now we have a problem with equality signs. So what we'll do is we'll find g of f0. Now f0 is when x is 0, f0 is 0. So it'll be this g0, and g0 is 2 into 0, 0. So we have to include this equality sign at a point where definition of g of fx is 0. So if we put 0 here, it will be 2. And if we put 0 here, it will be this 2x square. So we have to include this 0 here. And in the same way, we will find g of f1. Now f1, it will be 1. So it will be this g1. And g1 is this 3 minus x, which is 2. Now if we put 1 here, it is 2. If we put 1 here, it is 2. Now since it is continuous at 1, we can put this equality sign anywhere. So that is the definition of g of fx. Now we'll solve this using algebraic method. So here we have to find g of fx, which is 2fx when fx lies between minus 1 and plus 1, and it will be 3 minus fx when fx is greater than or equal to 1. Now fx has two definitions. So first we'll consider this definition. So now we write this as 2 and then x plus 1 when x plus 1 lies between -1 and 1, and the condition with that definition is x is less than 0. And here will be this 3 minus x plus 1 when x plus 1 is greater than or equal to 1, and here the condition is x is less than 0. Now next definition is x square, so it will be this 2x square when x square lies between -1 and 1 and x is greater than or equal to 0, and then it will be this 3 minus x square when x square is greater than or equal to 1 and x is greater than or equal to 0. Now we'll solve these conditions. Now this is -2 less than or equal to x less than 0, and this is x is less than 0. So intersection of these two conditions is this interval. So g of fx will be (2x plus 1) when x lies between -2 and 0. Now if you look at the second condition, here the condition is x is greater than or equal to 0, and here x is less than 0. Now there is nothing common between the two intervals, so this is not possible. Now if you look at this third one, x square is always greater than -1 and x square less than 1 is x lies between -1 and +1, and here x is greater than or equal to 0. So intersection is x is greater than or equal to 0 but less than 1. In this case, this definition is 2x square. And this third one is x square is greater than 1. That means x is greater than or equal to 1 and x is greater than or equal to 0. That means x is greater than or equal to 1. Then this definition is 3 minus x square. So this is the definition of g of fx using algebraic method. So this is how we find composite functions from two piecewise defined functions.
Now the seventh transformation that we'll study is how to draw the graph of linear modulus functions when they are added and subtracted together. So now first thing that we must keep in mind is this method is only applicable in the case of linear modulus function. Say for example, a function fx is given as mod of x minus 1 minus mod x and then plus mod x plus 1 for x belongs to R. Now the general way of solving this question will be I'll take up different intervals when x is less than -1, when x lies between -1 and 0, between 0 and 1, and when x is greater than 1. And for each of this interval, I'll write the definition of each modulus function separately and then I'll add them and subtract them accordingly. Now there is a direct method with which we can draw this graph. Now what I essentially know is in each of the interval, when I'll remove this mod sign, it will either have a plus sign or a minus sign. So in each of the interval, it will represent a portion of a straight line. So first I'll draw the axis. Now for mod of x minus 1, its definition changes at x equal to 1. The definition of mod x changes at x equal to 0. And the definition of x plus 1 changes at x equals to -1. So I'll mark these 3 points on x-axis. So I'll mark -1, I'll mark 0, and I'll mark +1. Now I'll find the value at each of the 3 points. I'll find the value at -1. So if I'll put x as -1, I'll get f minus 1 equals to 1. If I'll put x as 0, I'll get this value as 2. And if I'll put x as 1, again I'll get this value as 1. So I'll mark all the 3 points. So at -1, this value is 1. At 0, this value is 2. And at +1, this value is again 1. Now there is no definition change between -1 and 0 and 0 and 1. So that means between -1 and 0, I'll join these 2 points and I'll draw the straight line. And again between 0 and 1, there is no change of definition. So again I'll join these 2 points and I'll draw this line. Now also when x is less than -1 or when x is greater than 1, There is no change in definition. So again, in these intervals, I'll take up a random point and then I'll mark its value, maybe at -2. So if I'll put x is -2, the value I'll get is 3, -2, 1, 1 plus 1, 2. And also at 2, the value again will be 2. So at -2, this value is 2. And at +2 also, this value is 2. So again, I'll join these 2 points. So that's the graph of this given function. So in each of the case, it is going to represent a portion of a straight line. So in order to draw a straight line, all I need to do is I need to just mark 2 points. So that's what I have done in this case. So in case of any linear modulus function with a plus or minus sign, this is the simplest way of solving it. Suppose if I have to find the range of this function, so the minimum value of this function is 1. So range of this function will be y belongs to from 1 to infinite. So let us take up another example. Now here fx is given by mod of x minus 2 plus mod of x plus 2 and minus 2 mod x when x belongs to R. Now for this one, definition of mod x minus 2 changes at 2. Definition of x plus 2 changes at minus 2. And definition of mod x changes at 0. So I'll draw the x's and I'll mark these points. -2, 0, and +2. Now I'll also find the value at -2. So value at -2 will be 0. Value at 0 will be 4. And value at +2 again it will be 0. So I'll mark all the 3 points. Now since there is no definition change between -2 and 0, I'll join these 2 points. For 0 and 2 also, I'll join these 2 points. Now, when x is less than -2, I'll take any random point in this interval. Maybe I'll take f minus 3. So if I'll put x as -3, I'll get 0 again. And if I'll put x as 3, then again I'll get this value as 0. So again, I'll draw the straight line. So the graph which I have drawn in black is the graph of this given function. Let me take another example. So suppose the function fx is x plus 1 plus mod x minus 1 minus mod x. Now for mod x minus 1, definition changes at 1, and for mod x, definition changes at 0. Now I'll draw the x's and mark these 2 points. I'll find the value at 0. When x is 0, y is 2. So I'll mark the point. When x is 1, y is 1. So now I'll join these 2 points. I'll take up a point when x is less than 0. So when x is -1, y is +1. Again, I'll join these 2 points. And for this interval, when x is greater than +1, again, I'll take up a point. Suppose I'll take x equals to 2. I'll again get this value as 2. So when x is 2, y is 2. So again, I'll join these 2 points. So that's the graph of the given function. The 8th transformation is to draw the graph of functions which are of the form a minimum of the given functions or the maximum of given functions. Say for example, I'm given 2 functions fx and gx. So first I'll find their point of intersections. So I will equate fx equals to gx and then I'll solve this equation to get their points of intersection. Now suppose I have to find the graph of minimum of fx and gx. So it simply means whichever is smaller, I'll choose that value, and whichever is greater, I'll reject that value. Now when x is less than a, the graph of gx lies below the graph of fx. So minimum of fx and gx will be gx. So I'll choose the graph of gx. Maybe I'll choose it this way. Now when x lies between a and b, the graph of fx lies below the graph of gx. So I'll choose the graph of fx. Now when x is greater than b, again the graph of gx lies below the graph of fx. So I'm going to choose gx again. So the graph which I have drawn in black is the graph of this given function, minimum of fx and gx. And suppose if I have to choose maximum of fx and gx, then I'll choose the graph which lies above the other graphs. So I'll take up an example. Now say for example, I have to draw the graph of fx equals maximum of 1 minus x, 1 plus x and 2. So I'll draw the coordinate axis and I'll draw the three graphs. So the first graph is y equals 1 minus x, which is a straight line. So when x is 0, y is 1. When x is 1, y is 0. So that's the graph of y equals 1 minus x. Now the next graph is y equals 1 plus x. So when x is 0, y is 1. When x is minus 1, y is 0. So that's the graph of y equals 1 plus x. Now the third function is y is equal to 2, which is a constant function. So I'll draw the straight line. I'll also find their points of intersection. So if I'll put y equals to 2 in the first function, I'll get x equals to minus 1. So the point of intersection is minus 1. And if I'll put y equals to 2 in the second function, I'll get x equals plus 1. So the points of intersections are minus 1 and plus 1. Now, in this case, I'll need to find maximum of the given functions. So when x is less than minus 1, the graph which lies above the other two graphs is the graph of 1 minus x. So I'll choose this graph. So when x is less than minus 1, function is 1 minus x. Between minus 1 and plus 1, the value will be y equals to n, and when x is greater than plus 1, so the uppermost graph is the graph of function y equals 1 plus x. So that's the graph of maximum of 1 minus x, 1 plus x and 2. Now let us take another example. Suppose the function is given by fx equals minimum of 2 sin x, 1 minus cos x and 1 when x lies between 0 and pi. So first I'll draw the graph of 2 sin x. And then I'll draw the graph of y equals 1 minus cos x. Now in order to draw the graph of 1 minus cos x, my basic graph is y equals cos x. And then I'll take the transformation of minus cos x, which is rotate the graph 180 degrees about x-axis. And then finally take the transformation of y. Y minus 1 equals minus cos x. Shift the entire graph plus 1 units along x-axis. So the graph of y equals 1 minus cos x will be the graph in blue. And finally, I'll draw the straight line, which is y equals 1. Now for the minimum value, I need to choose the graph which lies below the given graphs. So between 0 and pi by 2, I'll choose 1 minus cos x. And then it will be y equals to 1. And then it will be the graph of sin x. Now I'll find this point of intersection. So if I'll put y as 1, I'll get 2 sin x as 1. So value of sin x will be 1 by 2. So this will be pi minus pi by 6. So there'll be 5 pi by 6. So graph of this function will be 1 minus cos x when x lies between 0 and pi by 2. Between pi by 2 and 5 pi by 6, its value is 1. And now between 5 pi by 6 and pi, this function fx will be sin x. So that is the graph of given function. Now I'll take third example. So the third example is fx equals minimum of mod x minus 2 and 2 minus mod of x minus 1. So first I'll draw the graph of mod x. So that's the graph of y equals mod of x. Next I'll draw the graph of y equals mod of x minus 2. So it'll be the same graph of mod x, but then I need to shift this graph plus 2 units along x-axis. So that's the graph of y equals mod of x minus 2. So if I'll solve these two equations, their point of intersection will be x equals to 1. Now we'll come to our third graph. And our third graph is y equals 2 minus mod of x minus 1, which is y minus 2 minus mod x minus 1. My basic graph is y equals minus mod x, and then I'll shift this graph to the point 1, 2. Now fx is minimum of the given function. So I'll choose the function which lies below all the functions. First one, I'll choose this. And then I'll also find their points of intersection. So the graph of this function will be 2 minus mod x minus 1 when x is less than minus 1. Between minus 1 and plus 1, this graph is mod x. Between plus 1 and 5 pi by 2, the graph is mod of x minus 2. And then again, from 5 by 2 to infinite, this graph will be 2 minus mod of x minus 1. Thank you. Now the next transformation is to draw the graph of functions which are of the form fx equals either maximum or minimum of some other function gt when t lies between a and x, when x lies between a and b. So this is generally not the way with which we represent our function, but then there may be some problems where a function is expressed in terms of another function. Now let us take an example. Now the function fx is defined as maximum of under root t when t lies between 0 and x, when x lies between a and b. So it simply means at any point x between a and b, t can take any value between 0 and x, and in this interval we have to find the maximum value of under root t, and then that value is assigned to this fx. Now let us take a as 0 and b as infinite. So I'll draw the graph of under root of t. Now the definition says at any point between 0 and infinite. So maybe I'll choose a point. So this point, it is x. T lies between 0 and x. So my t, it can take any value from 0 to x. And in this interval, I have to find the maximum value of under root t. Now in this interval, it is an increasing function. So the maximum value of under root t will be at the end of this interval. So that means at this point, the maximum value of under root t is under root of x. If I choose another point also, maybe now I say this is your x. Now again here, my t, it will lie between 0 and x. Now in this interval, again, it is an increasing function. So again, its maximum value will be at x. So again, its maximum value will be root x. For the interval where t belongs to 0 to x, the maximum value of under root t will be under root of x. So in this case, fx is under root of x. Now what if I change this question? Rather than taking it maximum of under root t, now I'll take it as minimum of under root t. Now again, I'll choose any point x. Now when t lies between 0 to x, the minimum value of under root x is 0. Again, if I'll choose another point x, so again in this interval, the minimum value of under root x is 0. So that means the minimum value of under root x in any interval will be 0. So this function will be a constant function and its value will be 0 for all x belongs to 0 to infinite. So in case of this, answer will be fx is equal to 0 when x is greater than or equal to 0. I'll take up another example. Now say for example, a function is defined as minimum of e to the power minus t when t lies between 0 and x, and when x lies between 0 and infinite. So I'll draw the graph of e to the power minus t from 0 to infinite. So that is the graph of e to the power minus t. Now if I choose any point x, the value of t will lie between 0 to x. Now in this interval, I need to find the minimum value of e to the power minus t. Now, because it is a decreasing function, the minimum value of e to the power minus t will lie at x. So here minimum value will be e to the power minus x. Now again, if I choose another value of x, so again in this interval from 0 to t, the function decreases. Now again, the minimum value of e to the power minus t will lie at x. So again will be e to the power minus x. So in this case, function fx will simply be e to the power minus x when x is greater than or equal to 0. Now, what if again I change it to maximum of e to the power minus t? Now, if I change the function to maximum of e to the power minus t, now at any point x in the interval 0 to x, the maximum value of this function is 1. So in the other interval also, the maximum value of e to the power minus t is 1. So in any interval, the maximum value of this function will be at 1. So in that case, it will be a constant function. So answer to this question will be fx equals 1 when x is greater than or equal to 0. Now we have discussed two simple cases when the function is either always increasing or always decreasing. In other cases, the function may be increasing as well as decreasing. Now suppose I'm given the graph of some function gx and I need to draw the graph of some function fx which is defined as maximum of gt when t lies between 0 and x, when x lies between 0 and infinite. So that means at any point x, I'll need to find the maximum value of gt in the interval 0 to x. Now between 0 and a, it is an increasing function. So maximum value of gt will occur at x. So in that case, the function fx will be same as gx. Now when x lies between a and b, now in the interval 0 to b, the maximum value of this function will be at a. So in that case, it will be a constant function. Now again, between b and c, it is an increasing function. So in the interval 0 to c, the maximum value of this function will occur at x. Now again, between c and d, if I choose any point x, then in the interval 0 to x, the maximum value will be at c. So then again, between c and d, it will be a constant function. And after d, it again is an increasing function. So my fx will be same as gx. Now in this case, I'm given the graph of gx and a function fx is defined as minimum of gt when t lies between 0 to x. So when x lies between 0 and a, it is a decreasing function. So minimum value of this function will lie at x itself. So in that case, fx is same as gx. Now when x lies between a and b, the minimum value of this function will be at a itself. So then it will be a constant function. Between b and c, the function again decreases. So again, fx is same as gx. And then between c and d, again the minimum value will be at c. So it will be a constant function. And after d, again the function will be a decreasing function. So then again, fx is same as gx. So that is the graph of fx. So let us take an example. Now suppose I'm given a function gx, which is x square when x lies between 0 and 1, mod of x minus 2 when x lies between 1 and 4, and 6 minus x when x is greater than or equal to 4. Now I'll need to draw the graph of fx, which is maximum of gt when t lies between 0 and x, when x lies between 0 to infinite. So I'll draw the graph of gx. Now between 0 and 1, it is an increasing function. So fx will be same as gx. Between 1 and this point of intersection. So I'll find out this point of intersection. Between 1 and 3, it will be a constant function. Then from 3 to 4, again it's an increasing function. So again it will be same as gx. And then from 4 to infinite, the maximum value is 2. So again it will be a constant function. So I can write this function fx as x square when x lies between 0 and 1, 1 when x lies between 1 and 3, 6 minus x when x lies between 3 and 4, and then 2 when x is greater than or equal to 4. So that is the definition and graph of this function fx. Thank you. For this question, I need to find values of a for which the equation mod x minus 1 plus mod x minus 2 plus x minus a has two solutions. So I can write this equation as mod of x minus 1 plus mod of x minus 2 plus x is equal to a. Now one way of doing it can be I can take three separate intervals, x is less than 1, when x lies between 1 and 2, and when x is greater than 2. Another way is using graphs. So I'll solve this equation using graphs. So I'll draw the graph of y equals mod of x minus 1 plus mod of x minus 2 plus x, and I'll draw the graph of y equals a. So we have already drawn such graphs in previous lectures. So here definition changes at 1 and here definition changes at 2. So I'll draw the axis. I'll find the values. When x is 1, value of y is 2, and when x is 2, value of y is 3. So I'll mark these points. So when x is 1, y is 2, I'll join this portion of a straight line. Now I'll take another point when x is less than 1. So maybe I'll take 0. So when x is 0, y is 3. So I'll draw this portion of a straight line. I'll take another point which is x equals to 3. Y is 6. So I'll draw it. It is given that this equation has two solutions. So that means I need to draw the graph of y equals to a so that these two graphs, they intersect at 2 points. So if a is less than 2, then this line will lie below this graph. So then there will be no point of intersection. If a is 2, in that case, there will be only one point of intersection. Now when a is greater than 2, then these two graphs, they will intersect at two distinct points. So then it will have two solutions. So this equation will have two solutions when a is greater than 2. So the question is, solve the inequality x square minus 4 is less than greatest integer function of x. Now what I'll do is, I'll draw the graph of y equals x square minus 4, and I'll draw the graph of y equals greatest integer function of x. So first I'll draw the graph of greatest integer function of x. And then I'll draw the graph of y equals x square minus 4. Now that is the graph of y equals x square minus 4. Now there are 2 points of intersections. For this point of intersection, I will write and this point of intersection is intersection of x square minus 4 and 2. So I'll get x as root 6. Now, in order to solve this inequality, I'll need to find the region where the graph of x square minus 4 lies below the graph of greatest integer function of x. So the graph of x square minus 4 lies below the graph of greatest integer function of x in this interval. So answer to this inequality is x belongs to minus under root 2 to under root 6. Now the question is, maximum of mod x mod y is less than 2 and mod of x minus mod of y is greater than 1. I need to find the area enclosed by these two curves. We'll start with the first one, and first one is maximum of mod x mod y is less than 2. So what I'll do is I'll draw the axis. I'll also draw y equals to x and y equals minus x lines. Now what we know is any point on these lines, it is equidistant from x-axis and y-axis. That is distance from y-axis, which is mod x, and distance from x-axis, which is mod y. So in this case, mod x is equal to mod y. Now in this region, if I'll take any point, it'll be closer to x than y. So this is your mod y and this is your mod x. So clearly mod y is less than mod of x. And in the same way, for this region also, it will be the same. Mod y is less than mod x. Now for any point in this region, it will be closer to y than x. In this region, mod x is less than mod y. And here again, in this region, mod x is less than mod y. Now the function says maximum of mod x and mod y should be less than 2. So that is, here it should be mod of x less than 2. Here it should be mod of y less than 2. Here again mod of x less than 2. And here again it should be mod of y is less than 2. Now mod x less than 2, it means x should lie between minus 2 and plus 2. And mod y less than 2 means that y lies between minus 2 and plus 2. So I'll draw dotted lines at x equals minus 2 and x equals to 2 and y equals minus 2 and y equals 2. So now it will look like, now for this region it is mod of x is less than 2. So that is x lies between minus 2 and plus 2. So the region I'll get is this small triangle. Now for this region again, I'll get x equals plus minus 2. So again, I'll get this one. For mod y less than 2, I'll get y lies between minus 2 and plus 2. And here again, I'll get y lies between minus 2 and plus 2. The region represented by this curve is the region inside this square. Now mod of x minus mod of y greater than 1, I can write it as mod of x minus mod of y is greater than 1, or mod of x minus mod of y is less than minus 1. So I'll plot these two regions. So for the first one, basic graph is x minus y is equal to 1. So I'll draw the graph. Y is 0, x is 1. X is 0, y is 1. Now I'll take the transformation of mod x. Erase the graph from second and third quadrant. Take the reflection of right on left. And then I'll take the transformation of mod y, which is erase the graph from third and fourth quadrant and take the reflection of up and down. Now I need to plot this inequality region. So what I'll do is I'll take origin and I'll put it there. So 0 is greater than 1, so which is incorrect. So that means the region represented by this curve is, so this inequality is represented by this shaded region. Now I'll come to next one, which is x minus y equals minus 1. When x is 0, y is 1, and when y is 0, x is minus 1. I'll take the transformation of mod x. And then I'll take the transformation of mod y. Now for inequality again, I'll put the value of origin. So 0 is less than minus 1. So which again is incorrect. So again, the shaded region is going to represent this inequality. So the region bounded by this given inequality is, so we'll need to find area bounded by given two curves. Now area bounded by first curve is area within this square, and area bounded by the second curve is this area. So the area which is common to both is area which I have drawn in red. This is 1, 2, minus 1, minus 2, again 1 and 2, minus 1 and minus 2. Now each of this area is a small triangle. I can find the area of one triangle. So area of any triangle is given by half. Now base is 2 units and height is 1 unit. So this is 1. So each of these triangles of area 1 square unit. So the area enclosed by these two curves is given by 4 square units. Today we'll discuss an interesting problem in geometrical probability. And the question goes like, if you break a pencil in 3 parts, what is the probability that the 3 parts can be arranged to form a triangle? Suppose we have this pencil, and suppose length of this pencil is L, Now we have to break this pencil in 3 parts. Suppose these are the 3 parts. Now suppose length of this first part is x, length of this second part is y, and length of this third part will be L minus x minus y. Now first we'll find uniform sample space for this given condition. So we know that this x, it should be greater than 0 but less than L. In the same way, y also should be greater than 0 but less than L. And the third one, which is 0, is less than L minus x minus y, and it should be less than L. Now here we know that x and y, they are both positive. So from the third one, we'll get this condition as x plus y is less than L. So we have 3 conditions. So x should lie between 0 and L, y should lie between 0 and L, and x plus y should be less than L. So we'll plot this region on a coordinate plane. So x, it takes the value from 0 to L. In the same way, y takes the value. So this is x and this is y. So y takes the value from 0 to L. So we have this region, which is this square. And then this third condition, which is x plus y is less than L. So I'll draw this line, which is x plus y is equal to L. So it'll be the straight line passing through these 2 points. And then x plus y is less than L. So if I'll put origin, so 0 is less than L, which is true. So that means we can break this pencil in 3 parts whose sample space can be represented by this uniform area, and which is area of this triangle. Now we need to find this condition that these 3 parts, they can be arranged to form a triangle. Now let 3 sides of a triangle be A, B and C. Now we know that A, B, C are sides of a triangle if they satisfy triangle inequality, and triangle inequality is sum of 2 sides is greater than the third side. So that means A plus B should be greater than C, B plus C should be greater than A, and C plus A should be greater than B. Now I will take A plus B. So what is A plus B? A plus B is x plus y should be greater than L minus x minus y. So from here I'll get x plus y should be greater than L by 2. Now from the second one, B plus C is greater than A. So what is B? B is y, and this is plus L minus x minus y. It should be greater than x. So here y will cancel. So here I'll get x should be less than L by 2. And from the third one, C plus A, C is L minus x minus y plus x, and it should be greater than y. So here I'll get y should be less than L by 2. So the condition that these 3 parts, they can be arranged to form a triangle is this x plus y should be greater than L by 2, x should be less than L by 2, and y should be less than L by 2. So I'll mark this region. So I'll take x as L by 2. So this is x is L by 2, and then I'll also have this y equals L by 2. So here x should be less than L by 2 and y should also be less than L by 2. So we have this square, and now this third condition is x plus y should be greater than L by 2. So first I'll draw this line, which is x plus y equals L by 2. Now this point is L by 2 comma 0. This is 0 comma L by 2. So I'll draw this line. So this is x plus y equals L by 2. Now if I'll put x and y as 0, I'll get 0 is greater than L by 2. So that means 0 doesn't satisfy this equation. So the area or the region that we'll need is above this line. So the condition that these 3 parts can be arranged to form a triangle corresponds to this blue triangle. Now we'll calculate this probability that these 3 pieces, they'll form a triangle. So What is the favorable area? Favorable area is this area of blue triangle. So this is half. Now what is the length of this side? So it is L by 2, and this also is L by 2. So half L by 2 into L by 2. And then what is the total area in the problem? Area of this black triangle, so which is 1 by 2. And then length of this side is L. This side is also L. So that is L into L. So half will cancel. L will also cancel. So this is 1 by 4. So which simply means if you have a pencil and if you randomly break it in 3 parts, then it is 25% chance that these 3 pieces will form a triangle. Now in question number 19, this function f is defined as x minus 1 into minimum of x or x square when x is greater than or equal to 0 and x into minimum of x or 1 by x when x is less than 0. So when x is greater than 0, if I'll draw the graph of y is equal to x and y is equal to x square, so this is y is equal to x line and this is y is equal to x square. So between 0 and 1, the function which is minimum is x square, and between 1 and infinite, minimum function is x. So I can write this function fx as x into x minus 1 when x is greater than 1, and this is x square into x minus 1 when x lies between 0 and 1. Now, when x is less than 0, I'll need to consider minimum of x and 1 by x. So, when x is less than 0, we have this 1 by x, and then we have this y equals x, and their point of intersection will be minus 1. So, between minus 1 and 0, this minimum value will be 1 by x, and when x is less than minus 1, this minimum value will be x. So I can write this as, so between minus 1 and 0, in that case, minimum is 1 by x, so 1 by x into x is simply 1, and when x is less than minus 1, here the minimum value is simply x, so now it will be simply x squared. Now I'll need to find continuity and differentiability of this function. So if I'll put x as 1, it will be 0. At 1, here also it will be 0. So it is continuous at 1. So if I'll put x as 0, I'll get this as 0. But if I'll put x as 0 here, it is 1. So it is discontinuous at x equal to 0. Now at minus 1, this value is 1. And at minus 1, this value is again 1. So this function is continuous at all points except at x equal to 0. Now I'll differentiate this function. So if I'll find f dash x, I'll write this as 2x minus 1 when x is greater than 1, 3x square minus 2x when x lies between 0 and 1. This is 0 when x lies between minus 1 and 0, and this is 2x when x is less than minus 1. Now when x is greater than 1, so if I'll put x as 1, I'll get this value as 1. So that means right hand derivative at 1 is 1. And if I'll put x as 1 here, I'll get 3 minus 2, which is 1 again. So that means this function is differentiable at x equal to 1. Now what about 0? Now we already know this function is discontinuous at x equal to 0. Now we know that if a function is discontinuous at a point, then it is not differentiable at that point. So that means this function is not differentiable at x equal to 0. Now what about minus 1? So at minus 1, right hand derivative is 0, left hand derivative is minus 2. So that means it is also not differentiable at x equal to minus 1. So this function is not differentiable at 0 and minus 1. So that means answer to this question is not differentiable at exactly 2 points. Now in question number 20, we are given this function f such that, now question number 9 is, fx is maximum of cos x and x square when x lies between 0 to pi by 2. If x0 is the solution of the equation cos x equals x square, then which of the following is correct? So we'll draw the graph of cos x at x square when x lies between 0 and pi by 2. So between 0 to pi by 2, cos x is a decreasing function and x square, it is an increasing function. So this is the graph of y equals x square and this is the graph of y equals cos x. Now these two graphs, they intersect at x naught. So this point is x naught. Now it says maximum of the two functions. So from 0 to x naught, the maximum of the two functions is cos x. So our function fx will be simply this graph. And from x naught to pi by 2, the function is x square. So that is the graph of y equals fx. Now this graph is continuous in 0 to pi by 2. It is differentiable everywhere except at this point x naught. So answer to this question is f is differentiable everywhere except at x naught, and that's your option D.